Good morning everyone. We are group 7 and we are doing the experiment called field density test by sand cone replacement method. So the sand cone replacement method is used to determine the field density of soil embankment and to know whether the desired compaction is achieved or not. With this, we have the objectives, which is to determine the water content of soil using the sand cone method and also the bulk or field density. The materials and equipments that we are using in this experiment are the following: sand pouring cylinder, sand cone, base plate or metal tray with central hole, sand, weighing balance or scales, soil and sand containers, trowel, sieve number 20 and number 30, and drying equipment, which is an oven.
Before starting the experiment, we will be weighing the tools that will be used using the triple beam balance. So I will now weigh the sand pouring cylinder. So the weight for the sand pouring cylinder is 348 grams.
So now we are going to fill the sand pouring cylinder with sand.
We are going to dig a hole with a depth of 4 inches using this metal rod and metal plate with central hole.
So since we're done digging up a hole which is in the depth of 4 inches, we'll be filling it with sand using the sand cone and also the sand pouring cylinder. Now we'll be opening the shutter so that the sand will pour directly to the hole until there is no further movement in the pouring cylinder. So now we are weighing the sand left in the pouring cylinder for trial 1. So this is the remaining sand for the sample 2. So we have filled up the depth of the hole, which is 4 inches, and this is the remaining sand, and this is the width. This is the sample for the soil for trial 2.
Now we are weighing the remaining sand of sample 3.
This is the soil sample for sample 3.
So now these are our soil samples ready to be put in the oven. This is sample number 1, sample number 2, and sample number 3.
Now we are going to put the sample in the oven. Sample 1.
Pinakataas. Oops.
Atong ibutang ang form. Pila tong amount sa tubig? 11.
Sample 2. And sample 3.
11. Muna siya ang
So for every experiment that we will be doing, it is important that we have a reference standard. So for this experiment, we have the reference standard of ASTM D1556, or it is also known as the standard test method for density and unit weight of soil in place of sand cone method. So first, we have here the results of our table 1, which is all about the bulk density data sheet. So we're just going to do a run through of this. We have the mass of sand of cylinder before pouring, mass of the remaining sand of every trial that we'll be doing, plus the cylinder after pouring. So we have all these data, sample 1, sample 2, sample 3, and the average for it. And we also have here the mass of sand, which is M1 minus M2. And also we solve for the density of the sand, which I'll be showing you the calculations later. For the total volume, we also have this one, 5,000 grams per cubic centimeter. The mass of excavated soil metal trays, this is without the soil. So these are only the mass of the trays. Then we have the mass of the excavated soils. So we just minus it with the metal tray. And lastly is for the bulk density. Next, for table 2 would be more on the water content data sheet. So we have 3. This is the mass of the soil sample. This is considered as the M3. So we have the sample 1, sample 2, sample 3, and its average. And we also have the mass of dry soil sample. This is already after being put in the oven for 24 hours. So we have these data. And lastly is for the water content for each sample. And we have an average of 0.187. Or if we want to convert it into a percentage, we just times it by 100 and we have the 18.7%. Lastly would be the dry density for each sample, and we got the average of it also. So here are the calculations. For the density of sand, we have the mass of sand over the volume of the cylinder. So we have this for sample 1, sample 2, sample 3. And for the water content, we solved it using the mass of water over the mass of the dry soil sample. Next would be the bulk density, which is the mass of dry sample over 1 plus the water content. And lastly would be the dry density, which we solved using the bulk density over the 1 plus the water content again. So we have here the average bulk density, water content, and dry density. So for the bulk density, we have the 1,014.79 grams per cubic centimeter. For the water content, as what I've said earlier, it is 0.187 or 18.7%. And lastly, for the dry density, 854.63 grams per cubic centimeter. So the quantity of dry density is largest when the amount of moisture content is least. So this is due to the fact that when water is given to soil with low moisture content, it becomes simpler for the particles to pass one another when compacting is applied. So the gaps are smaller as the particles get closer, which raises the dry density. So for the reference standard, again, these are the two important standards that were cited in the scope. So we have the 1.2. The test method is applicable for soils without appreciable amounts of rock or coarse materials in excess of 1 1/2 inch or 38 mm in diameter. So we made sure that the excavated soil that we did
did not have any large amount of debris or did not exceed to a 38 mm in diameter. And the second one would be 1.6. This test method has been written using the gravitational system of units when dealing with the inch-pound system. In this system, the pound represents a unit of force. However, the use of balances or scales recording pounds of mass or the recording of density in pound per cubic feet should not be regarded as non-conformance with this test method. So with this is only the standard that we did not follow. Since based on the standard, as what I've said earlier, this experiment uses the pound mass per cubic feet unit for the density. However, in our experiment, we used the grams per cubic centimeter as a unit for density, since it is much more appropriate and easy to express values using this unit, and considering this is an SI unit. Thank you.